I do need to go over it?
Yeah, of course. I mean, if you need to. So.
All right, so where will you start? I was thinking we would start, let's see, hang on a minute. Let's start right here. First of all, there's only 4 more lectures, including today, April 2nd, Monday of next week, Wednesday next week, Monday, April 14th, plus that's your last day to handle late items. There are 6 zeros that could be turned into 40s, old zeros, so it could be yours. I can't remember whose they are, but look at your scores. Make sure you don't have a zero, because a couple of them from way back, week 2 and week 3 are some of the zeros. So make sure you don't have a zero. Your first part of final exam is on Wednesday, April 16th at 2 o'clock. That will be about a 40 minutes, my guess. Then your part 2 of your final exam 5 days later. Is that 5 days? April 21st at 3 o'clock. That will be about an hour, from 3 to 4 approximately. Same rules as always, open book, open notes, same deal. But only 3 more lectures after today, so 1 of 4 lectures is right now. What do I want to start with here? What was I thinking? Hang on a minute, I was thinking something, I can't remember what it was. I'm going to start with this, what we didn't get to on Monday, which is this a little bit of review, but it's doing the correlation coefficient again. Have the rules for DIST ready, and the rules for TINV ready. All right. Meanwhile, well, here's the example. I'm going to go fast because this is just review, and that is it's a one-tailed hypothesis. The correlation coefficient greater than or equal to 0. The correlation coefficient less than 0. Why is this alternative less than 0? Because look at our correlation coefficient. It's a negative number. And if it's one-tailed, that means the alternative would be less than 0. 30 observations. This is all the information you have. 1% significant. The question says, show your work manually to determine what the test statistic is. That's going to say in the instructions. And then it's going to say, explain if you can reject or not reject the null hypothesis. And then tell whether this correlation coefficient is significant or not significant. At your first guess, before we go through this, is this significant or not significant? Is this significant? Negative 0.60, 1% significance. Is that correlation coefficient, if you had to guess, significant or not significant? I hear significant, I hear not significant. Vote for one of each. Someone break the tie. What? We're changing our mind? Okay, we're going significant. For 2 people going significant. Here we go. What's our first step? You remember the formula? I believe to find our test statistic, isn't it the correlation? So I'm going negative 0.60 times what? Is it the square root of our sample size minus 2?
Yes.
So times the square root of our sample size, which is 30 minus 2. So that would be the square root of 28. That's our numerator. The denominator, I believe, starts with the square root, 1 minus, now I'm putting parentheses because we got to square this, negative 0.60 squared. And then this square root goes over the whole thing. That's how it goes. I better get my notes because I don't want to have to do all this math. So, let's talk about order of operations. Ready? I don't have all the details here and what the calculations are, but here's the steps I would take. With the numerator, I'd say, okay, 30 minus 2 is 28. What's the square root of 28? I'd get that number, then I multiply it times negative 0.60, and you end up getting, let me make sure I got this right, negative 3.1749. The denominator, order of operations, square that negative 0.60 first. Negative times a negative is positive. 0.60 is going to be 0.36 is my guess. I don't know if you guys got a calculator. Now you got to subtract it from 1. It turned positive because you squared it. It got rid of the negative. So if that's 0.36 or whatever I said, subtract it from 1, we're at 0.6 something, 0.64. Now square root it. You should get, someone hopefully is checking this, 0.8, 0.8. I don't know if anyone's checking this. Now you divide your denominator in your numerator. I end up getting negative 3.969 is our test statistic right there. So there's our first step. Now, let's say it says to solve it using p-value. I'm going to go ahead and use the T, don't forget this is all T for this correlation coefficient. So I've got equals T, D, I, S, T, parenthesis, drop the negative. Does that sound right?
Yes.
Drop the negative. 3.969, comma, degrees of freedom. Here it is, 30 minus 2, 28, comma, is this one tail or two tail? This happens to be a one tail. I did all that, I get a p-value of, are you ready? I gotta make sure I got this right. 0.000228. Look how many places to the right of the decimal I had to go just to get to a number. 1, 2, 3, 4 digits to the right just to get to a 2. This is really a low p-value. This p-value is darn close to 0 because look at all the zeros in front. Here, if a 1 were here, that'd be 1%. If a 5 here, that's a 0.5%. It's less than that. Now, the significance 1%, so I say less than 1% significance. Therefore, we reject or not reject?
Reject.
Reject it is, very good. Reject, now here's the hard part. Here's the hard part. Is this correlation coefficient significant or not significant?
Not significant.
Stop! We're rejecting the null hypothesis. It is significant, don't forget. Whenever you reject, now look at your notes. If I said it differently, then maybe I'm wrong, I don't know. But look, if we're rejecting the null hypothesis, that means the correlation coefficient is definitely less than 0, far enough away from 0 to have relevance. Meaning there's definitely a negative correlation. While one of the variables is going up, the other variable is going down at this negative 0.60. Even though it's just a medium correlation, right? If I had you describe it, what are the two words you'd use to describe this? Remember those words from Monday? What are the two words?
Strong.
No, this isn't strong.
Weak. Medium.
No, it's not weak. God, there's only one left.
Medium.
Okay. Medium what?
Medium. Strong.
No, what's the other word right here? Negative medium, remember? That's how you describe correlation coefficients. But you don't know if it's significant or not, but it just so happens that it's medium, you know? It could be significant, it may not. It all depends on the sample size. Because this sample size was so large, this became very significant. Because the sample size was so large. We do negative 0.60 with a sample size of 10, and I bet you that's in no way significant. It'd go the opposite direction. So the sample size has a lot to do with this correlation coefficient, whether it's significant or not. Don't get me wrong, you get a correlation of negative 0.98 or positive 0.98, that's so correlated that you don't even need to do this because you know it's probably significant. It's the medium ones and the weak ones that you got to do this to figure out whether they're significant or not. But when you're rejecting the null hypothesis, that means your correlation coefficient is significant. All right, so there's your review. We're going now to regression. Regression, let me get this off here. We're going to regression. Oh, wait, oh my God, I almost forgot. What was that, hang on a minute, what was that test statistic? Negative 3.969, is that the test statistic?
Yeah.
I almost forgot. Equals T-I-N-V, parentheses, the significance is 1%. What do I put here? 1.01?
0.01 times 2.
Whoa, stop it. Is it times 2?
Yeah.
All right, good one.
Significant.
0.02 then, right? We double it because it's one tail. Would you, all right? We double it because it's one tail. Degrees of freedom was how many? 20 or 30 minus 2? 28. If I had that on my paper, what does this equal? 2.46 equals 2.46714.
So it does not fall.
Hang on a minute, this is plus and minus. Plus and minus 2.4674. Think of a number line. Negative 2.4674, positive 2.4674. Now our test statistic is at negative 3969. Outside or inside our critical values? Outside our critical values, which means we reject or not reject? Reject, very good. Anytime our test statistics outside the critical values, we reject. So you've seen now how to determine whether this is significant or not significant using both approaches, p-value and critical value as a review. So let me get this back off here. All right.
Boom, 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 boom.
Now, we gotta go to regression, so let's switch gears over here. Here's regression. I'm gonna put this, whoops. I wanna put this up on the slide.
So it's 2.4.
It was, 2.46714. 2.46714 plus, put plus and minus in front though, because that's your critical data. Okay, linear regression, one of the most important things you're gonna learn this semester, especially if you're a county major, county majors especially. There's two variables, there's an X and a Y. I went ahead and set one up here, so it looks, this is a perfect example of maybe a final exam question, where you have 3 pieces of X's and 3 pieces of Y. Here's what I want to explain to you, this may be a good multiple choice question, is that the X's are what's called the explanatory variable. It's the one, I wanna make sure I get this right, this is the one that in most cases, we have some control over. Let me use like, let's say you're managing a huge Walmart grocery section. You're the grocery store manager for Walmart. And you got this extra supply of milk or something like that, and you have all kinds of detailed records. How much milk you sold every day, what the price of milk was for that day. You have detailed records of how much milk you sold every hour of whatever day it is. So you can literally go back over time and use history and use those numbers in a regression model to forecast how much milk you're gonna sell based on whatever price you set it at. Hey, let's lower the price a little. Let's go to $2.20 a gallon, because we have these gallons that have expiration dates on it, and we haven't moved it in the last few days like we should. We're gonna lower the price, and you can determine exactly 1 penny less, 2 penny less, or 3 penny less, how many you're most likely gonna sell using a regression model. It forecasts for you based on history of the exact same information. So it's really useful in a lot of management tools. Explanatory variables, the one you kind of have control over. In milk, in the price of milk and how many gallons we sell, or however many half gallons we sell, what we have control over is the price. That's the explanatory variable. We are the ones who adjust the price. The response variable is how many you're gonna sell, for example. Now, I was just using milk as a, an arbitrary example. In this case, X has a 6, a 4, a 2. Look at what happens to Y as we change X. X is going down, Y is going down. They're going the same directions. If we were to calculate a correlation coefficient, do you think it would be positive or negative? Now, don't base your answer on because the numbers are going down, you think it's negative. It's based on what's happening to the other variable as the number's going down. Are they going the same direction or opposite directions?
Same direction.
Same direction. That's why it might most likely will be a positive correlation coefficient. It's opposite directions that you get the negative correlation coefficient. But we need to get a regression. Now here's the formula for regression. Matter of fact, let me get it up on the slide for you too. I want to make sure you can see it.
We don't have to just put it in the Excel.
No, you're manually calculating this regression model. And the 2 items you're gonna get is what's called the slope, B sub 1, and the intercept, B sub 0. The intercept and the slope. There they are. Looks like some big formula here. The sum of X minus the mean of X times Y minus the mean of Y is your numerator. The sum of X minus the mean of X squared is your denominator. You got it. The easiest way to do this is to form columns. Man, this is what I used to do all the time. Just form these columns on Excel spreadsheets. Form columns. And this way you can change any number and change all your numbers for you and go right to that forecast that you're looking for. But here we go. You form columns and you say, okay, I'm going to attack the numerator first. I'm going to take it one piece at a time. I want to find out what this number is for every one of my X's. X minus the mean of X. So to do that, I got to find the mean of X. What does that equal? You're going to, what?
4.
Is it 4? No.
Oh,
Wait, let me check.
Is it 6?
No, it's 4, you're right.
Oh, now you're going to click on what's over.
It's 4. you add 6 and 4, which is 10, plus 2 is 12. 12 divided by 3 is 4. Let's do y. Hang on a minute, we're gonna make room here. Mean of y. You say 7? Okay. 10 plus 6 is 16, plus 5 is 21, divided by 3 is 7. There it is. Now I look at my formula. I need each x minus the mean of x. Each x. So right here in this column, x minus the mean of x. A line over the variable that stands for mean. So this is that column. You take one column at a time. Well, I'm sorry, one row at a time is what I meant to say. So here I go. 6 is my x minus the mean of x, which is 4. That equals 2. My next x. 4 minus the mean of x, which is 4 again, 0. The next x, 2 minus the mean of x, which is 4, negative 2. There it is. I just did this one right here. I'm now going to do this right-hand side of the numerator. Y minus the mean of y. I'm going to make that column right here. Taking each one of these y's, subtract 7 from it. 10 minus 7, 3. 6 minus 7, negative 1. 5 minus 7, negative 2. Go ahead. I heard something. No? Okay. Again, I took each one of the individual y's and subtracted the mean of y, which is 7. 10 minus 7, 6 minus 7, 5 minus 7. Now I did the right-hand side of the numerator. The numerator says to multiply these. I gotta multiply them. So now I gotta take every number from this column that lines up with every number from this column, the third and fourth column, and multiply them straight across. 2 times 3, 0 times negative 1, negative 2 times negative 2. So this column is gonna be called, hang on a minute, it's gonna be called, let me make here, x minus the mean of x times y minus the mean of y. Pen's running out. Gotta switch colors. Straight across. 2 times 3, 6. 0 times 1, 0. Negative 2 times negative 2, 4. Now, the last step in that numerator says, after you got this whole column here of x minus the mean times y minus the mean for every one of those variables, sum it. Add them up. So I'm just going to add that last column. 10. There's my numerator. For my slope is now 10 over, I got to do this denominator. This one is x minus the mean of x, which we've already done. We already have this column, but we have to square each one of them. So I got to make a column right here now. X minus the mean of x squared. I'm just going to the column x minus the mean of x and square each number. 2 squared, 0 squared, negative 2 squared. 2 squared, 4. 0 squared, 0. Negative 2 squared, 4. Then the formula says once you get that column of all those squares, sum up. Add it up. Sum up. Add them up. 4 plus 0 plus 4 is 8. 10 divided by 8 equals 1.25, I think. Let me check my notes. Where is it? 1.25. We just found the slope for these variables, 1.25. Basically, it says for every unit, x changes, y changes about 1.25 units. Either that or I have it backwards, one or the other. It's the slope, though. As one changes, the other changes by 1.25. Next, the intercept. Where does it all start? The intercept. This formula says to find the intercept, you take the mean of y minus the slope you just calculated times the mean of x. So the mean of y is 7. So we're going 7 minus 1.25 times the mean of x, 4. 4 times 1.25 is 5, I think. Does that sound right? 7 minus 5 equals 2. Let me check my notes. That's what I got there. 2. There's our intercept. All right, so everybody see how I got the slope, how I got the intercept, and now the forecast. All we needed was those two numbers. I can forecast any x now. Hey, what happens if x is an 8? What happens if x is a 1? What happens if x is a 10? I can try all kinds of different numbers, and now that I have the slope and intercept, it will forecast what y will most likely be. There'll be high probability of y turning out to be this. Here we go, let's go with our first forecast. Give me a number x could be other than 6, 4, and 2. Give me a different number. 9, here we go. If x is 9, which is right there, that's your x, times your slope, which is 1.25, so 1.25, get your calculators out. You then take that result and you add it to your intercept, which is a 2. So 9 times 1.25 is going to be, let me see, what's a quarter of 9? Hang on. Half of it's 4.5, half of that's 2.25. So we're looking at 9, 10, 11.25? Yeah. 11.25 plus 2 makes 13.25. So if x were to be 9, if we set the price of whatever this is to $9 instead of $6 or 4 or 2, we will most likely sell 13 and a quarter, right about 13 of them, of whatever that item is, approximately, over the same period of time, whatever the period of time is that we've been selling Y. Does everybody see how this works though? X and Y would be something though. In my case, it was time was X. X is a very common to have time. Sometimes I'd have like 6 years data, or let's say 5 years at 12 months, I have 60 units of data. 1 represents the 60th month ago. 1, 2, 3, 4. Number 60 is last month. The most recent month is your biggest number. If you're using time as your X. Go ahead.
So you were gonna give us the X, correct?
And the Y's. The X and the
No,
Y's.
I mean the slope X.
Say it again.
You used 9 for it.
She's
So
wondering
I
where you
thought
got
you
9 from.
Oh, this 9, yeah, I'm gonna get that to you. I said someone pick a number, but instead I'm gonna say, hey, if X is 9, forecast what Y will be. But it'll be like, if you set the price at $9, forecast what those umbrellas will sell, how many of those umbrellas you'll sell. That'll be the story kind of.
How did you get that last column over there as well?
This one right here?
Yeah.
I went to this column, X minus the mean of X, which is what you really need, but the last step is to square it.
Okay.
So I took 2 squared, 0 squared, and negative 2 squared.
Okay.
So it's that column squared, and that's your denominator, is adding that up.
Sweet, thank you.
Okay, now, let me show you something. Let me check my notes. Let me make sure we're ready for this. Where's my other piece of paper? Here it is. So, now, here's what I want to show you. This is using Excel to do the same thing. So I want to show you here, look at the X. In this particular case, all of X here is time, 1 through 12 months. We have 12 months of historical data. That number 12 will be the most recent month. That number 1 will be from 12 months ago, the oldest piece of data, and it will be in order according to time. Here's our Y, 32, 30, 28, all the way down to 23 most recently. Now look what's happening. As the month number gets larger, our Y gets smaller. If we were to find the correlation coefficient, it would probably be a negative correlation because one number is going one direction, the other number is going the other direction. But we want to find the slope and intercept. So look what I did here. I said, okay, let's start with X minus the mean of X. I first had to find the mean of X, so right here, look at how I used. I used equals average C8 dot dot C19. Found the average of all that data, 6.5. Then I went here, look at E21, average E8 to E19, all that Y data, there's the average. Now I gotta find X minus the mean of X. So I took each X, like C8, C9, C10, minus C21. Now, what I should have done is I should have had a dollar sign in front of the C and a dollar sign in front of the 21. So then all I had to do was copy and paste. And the C, the first variable, C8, turns into C9, C10, C11. But with a dollar sign in front of the C21, that will always be C21. So we'll always subtract, watch what this is, minus C21, minus C21, minus C21, minus C21. You would always be subtracting the mean of X. Here's Y minus the mean of Y. You're always subtracting E21 because you're subtracting the mean of Y from every one of these Y's. E8 minus E21, E9 minus E21, E10 minus E21, E11 minus E21, minus E21, minus E21, minus E21. So there's those two columns. Those are the first two columns that were right here. Now what I do, okay, for the third column, I said I'm going to take this column times this column. 2 minus 3, 0 minus -1 on the board here. Well, in this case, it's cell H8 times J8. H8 times J8, H9 times J9, H10 times J10. Now, why am I pointing this out to you is because let me show you your homework. Here's your homework. Almost looks very familiar. Looks just like the example I have up there. But you have to form the columns. You got to form the column X minus the mean of X. And I want you to use cell location formulas to put all the numbers in, just like I'm doing on that example. The next column, Y minus the mean of Y. Put cell locations in. That cell location times the mean. Minus the mean. That cell location minus the mean. So on. Put again with this. You can put that cell location times that cell location for this column. This one's going to take you a little bit of time, only because, and save yourself time. Use dollar signs and copy and paste. You just have to type out the first one. Let me give you an example real quick. I'm going to do the first one right here. I put X minus mean of X. There you go. I don't know, something like that. Maybe I'll make it a little wider. Here you go. Now, in this case, let's pretend the mean of X is right here. I'm going to make the mean of X 7.5. This is hypothetical. Hypothetical. Now, watch what I mean by cell location. Equals, where's X? B6 minus dollar sign B dollar sign 22 parentheses. I don't need parentheses. There we go. And right there, 6.5. 1 minus 7.5. Now, I had to type it in the first one. Watch what I do. I just grab onto it, push down my left click right there in the corner, and I just drag it down, copy and paste the whole thing. And it does all the rest of it for you. So each one of these columns, you only need to type the first line. If you use the dollar signs correctly, excuse me, correctly, just copy and paste them from that point down. You do the second column, do the third column. Let me go back to the example now so you can see what's going on. Here's the third column, H10 times J10, H11 times J11, blah, blah, blah. Now you have those three columns. Here's the fourth column, X minus the mean of X squared. I'm going up to H, column H, where it's X minus the mean of X, and then I'm just taking each number and squaring it. H8 squared, H9 squared, H10 squared. Then I add up that whole column. There's my denominator for the slope. Look at L21. I added up that whole column up above here. Hang on. I added up that whole column. That's this column. There's my numerator for the slope. There's my denominator for the slope. Same here. There's my numerator for the slope. And there's my denominator for the slope. So the slope right here should be saying L21 divided by H37. So let's take a look if it says that. There it is, equals L21 divided by H37. It's taking the numbers from the bottom of these two columns and dividing it to find your slope. The slope for this data is a negative 0.68182. The intercept. The intercept should be, where's our intercept? The mean of Y minus the slope we just calculated times the mean of X. Well, it's gonna, look at where the means are at, they're way up here. So it's gonna take the mean of X, which is in C21, then it's gonna take the mean of Y times the slope, which is, the slope is right there, we're in it, C24. So here it is, E21, which is the mean of y, minus C24, there's C24, the slope, times C21, which is the mean of x. So there's our intercept, 30.84848. Well, on your homework, let me go back to your homework. Oh, is this it? No, that's the other homework. We'll talk about that in a minute. On your homework, which is right here, I want you to do the same thing. Somewhere on here, maybe right down here like I did, or way over here if you want to, put the formula for your slope and intercept. And once you get your slope and intercept, you're done. That's all you gotta do with this one. Get to this point, your slope and your intercept. Get to that point on this spreadsheet using cell locations for your formulas, just like the example, and you got this one done. Now look, if you're copying someone else's, at least like move it to a different spot. Don't put the slope and intercept in the exact same cell that the person you're copying off of put it. At least like show you can put it in a different spot and still figure out how to write the formula or something. All right? Okay.
Gotta
Good.
take that one off the camera.
Take what I just said off the camera. Oh yeah, I don't want to call you all cheaters on camera. Stop it. All right. How do we feel? Can we do this homework assignment? Can we do the regression? Can we get the slope? Now, next week on Monday, we're going to take this farther. We're going to do a bunch of forecasting. So we're going to find the slope and intercept and then do forecasts. Because the forecasts are what you're using as managers all the time. All right, there's that part of the assignment. Now, look at this part of the assignment. Whoops. Man, where is it? Right here? Oh, and I gotta get rid of this. I gotta get this back off here. This is the one I just did, right? So I gotta get this off here. Hang on. So now I'm gonna take this blank spot and go here. Boom, gone. Oh, I gotta get rid of this. There. For the other class. Now this part of the homework says, hey, you got an X and Y, and it wants you to do several things. First it says, find the correlation coefficient using the Excel equation CORREL, right there at the top of the board. I'm going to show you how to do it here in just a second. Then it's asking you to find the test statistic. We're going to find the test statistic the same way we found the test statistic when we calculated it right here. Exact same way. Then it says to find the 1 and 2 tail p-values using the Excel equations. This one's p-value, so you know it's T DIST. Let me repeat that. You know you're going to be using T, DIST, or whichever other Excel equation you feel comfortable getting the p-value from. If you want to use that T, 2T, dot, whatever that one is, you can use that one, whatever one you want. As a matter of fact, in my example, I show you both ways. Then you answer this question, which says, at 5% significance, two-tail, you're going to use the two-tail p-value, can the null hypothesis be rejected, and is the correlation coefficient significant? Answer both these questions. Can you reject, and is it significant? And show your work, what you're comparing. So now, let me show you the example. Here is an example. Here's our X, here's our Y. I'm going to find the correlation coefficient right here using the formula right there. I could just, matter of fact, I could just copy that and paste. It's the CORREL, the location of the first set of data, and the location of the second set of data, the second variable's data. The test statistic, look at what I did here. It's using the correlation coefficient times the square root of, now there I put 9 minus 2, I cheated there. I should have put count, and I should have counted how many pieces of data I had, minus 2. But I counted instead manually, 9 minus 2, divided by SQRT, the square root of 1 minus K8, that's your correlation coefficient, squared. So once I figure out the correlation coefficient, this number is going to, this test statistic is going to calculate automatically, because I have it all set up to look at K8. Look down here. I have equals T DIST. Now here's something you haven't seen. ABS, parenthesis, K10, K10 is the test statistic, comma, 9 minus 2, there's your degrees of freedom, comma, 1 for one tail. What's ABS? Absolute value. Don't forget, when you use TDIST, just in case it's a negative test statistic, I got to get rid of the negative. So I put absolute value there for the test statistic entry just to make sure it gets rid of the negative. And it only has to be when you're using TDIST that you have to do that.
Can you use dollar signs also?
You can use dollar signs if you want to also. The only difference between this one right here and the one below it is that I put a 2 on the end instead of a 1 to make it two-tailed. So here we go, equals TDIST parentheses, absolute value, ABS, K10, where the test statistic is, comma, 9 minus 2 for degrees of freedom, comma, 2 for two-tail. So once I get this correlation, it's gonna automatically calculate the test statistic. It's automatically gonna calculate, why does it say 0.5 there and 1 right now? Because it thinks the test statistic's 0. Think of the bell curve. Right at 0, at one tail, from 0 over is 50% of the bell curve. The whole bell curve, which would be the whole bell curve, would be 100%. That's why you got a 1 there for two-tail. And then the question down here has to be answered. But here we go. Equals correlation. So I'm going to type it out instead of copy paste. Equals CORREL parentheses. Now, where's the first set of data? I left click on C8, not the word X, just the numbers. See, I'm holding down my left click. I'm dragging to get all the data there. I let go. C8 dot dot C16. I'm hitting comma.
E8 now.
Now I'm doing left click on E8. I hold it down. I drag. Whoops. Drag. So let go E8 through E16. Now right parenthesis. When I hit enter, here's our correlation coefficient. It's automatically going to calculate the test statistic. It's automatically going to calculate one-tail and two-tail p-values. Here we go. Our correlation is a negative 0.52. Our test statistic is a negative 1.6. Our one-tail p-value is 0.075. Our two-tail p-value is 0.1500. At 10% significance, two-tail is the correlation coefficient significant. Let me repeat that. At 10% significance, look at two-tail, is your correlation coefficient of negative 0.52 significant? Yes or no? Is it significant? What are you looking at? Yes, it is, he says. What? Can you reject, yes or no? Can you reject? How's that? I'm going past reject. I want to know if it's significant or not. He says yes, based on, did you reject or not reject? He didn't even look whether to reject or not. You can tell by the smile on his face. He forgot to look at that part. Can you reject or not reject? Jake, give it to me.
No.
Why? Because the significant, or because the two-tail p-value is what? I can't see it. 0.15, is that what it is?
Yeah.
Two-tail p-value is 0.15, our significance is 10. Our p-value is greater or less? Greater than our significance, therefore we can or cannot? Cannot reject. Therefore, is our correlation coefficient significant or not significant?
No.
Not significant, because we couldn't reject. Exactly. You won't forget on the quick test, no?
Oh, I won't know.
That's right. Everybody see how to do this? Can you do, let me show you your homework now. Hang on, let me find it. Is this one it? No. Here's your homework. You have two sets of data also. This asks you to put together an Excel equation anywhere right here to give me the correlation coefficient. Here, this asks you to give me an Excel equation of some kind, just like on the example, to calculate the test statistic. Give me an Excel equation here using whatever Excel to find the one-tail p-value there. Give me an Excel equation there, or here, wherever, to find the two-tail p-value. Then answer this question. This question, though, is at 5% significance, not 10%, 5% significant. It is asking you to use the two-tail p-value. Wants to know if you can reject or not reject the correlation coefficient, and tell whether that's significant or not significant, please. It's asking you for significance also. Everybody understand what's expected on this homework? This one's going to go fast. The other one, it's easy, but you get all those columns of form and all that copy pasting, so that will take a little bit of time. And then I want to remind you of the written part of the homework. Here I'm giving you, look, it looks just like this. I'm giving you the null hypothesis, I'm giving you the alternative. This time it's 26 observations, and the correlation coefficient is 0.35. Before you calculate anything, how would you describe the correlation coefficient 0.35? Can't hear you. Come on, there's a lot of mumbling. How would you describe it? 2 words.
Medium significant?
Medium, positive. There you go. It's a medium positive. It's 0.35, but barely medium. Barely medium. We don't know if it's significant or not because it's darn close to being to 0. It could be right on the edge. And we're using 5% significance. Your homework though, here's the key to it, and that's why when I went over this example, I got back up here and did TIMB, because you gotta do your homework, both p-value and critical value. Everybody see that? So, calculate your test statistic, then do your TDIST and tell me if you reject or not reject, and then do your TIMV, tell me if you reject or not reject, then explain whether it's significant or not, somewhere on there. You only have to do explain significance once.
Wait, did we say that if the correlation coefficient is negative, and then it would be, the alternative would be less than?
Correct. So look at here, notice the, oh, good observation. I made a mistake on the in-class. Oh, let me change it right now. I already posted this though. Darn.
What happened?
I made a mistake on the in-class. This is supposed to be a negative 0.35. Oh, this isn't an in-class, this is the homework. Oh, I made a mistake on the homework. Someone's already handed in the homework too. Oh. Let's take 1/8 of a point away from me. We can figure out how. Everybody understand how to do this homework? Even though there's a mistake on it, just ignore the mistake, who cares? Should I correct it and put it back and repost?
Do you want us to change the alternative or change?
I'll just change, and it'll be a lot easier for those who already did, just for me to change this to a greater than, and then this to a less than equals. And now it's correct, right?
So wait,
There, let me hit save, and I'll repost this tonight, so it's correct. But gosh, just do it the way it is. I'm not gonna take 8 points off because you're using the wrong hypothesis. I'm the one who gave you the hypothesis.
so it's just.
It's not gonna change your answer at all.
Oh, okay, okay.
By me putting the wrong hypothesis isn't gonna change your answer at all. I just corrected it though.
Okay, it's still 1 tail, yeah, so. Well, wait,
Yeah,
the
still 1 tail, exactly.
Coefficient's still positive, 0.35?
Yeah, it's still positive 0.35 because I changed the hypothesis instead. It's a lot easier that way. For those who already did it that way, their answer's not gonna be wrong. All right, you ready for the in-class? Oh, more questions?
I have one question regarding the Excel. For Excel.
Yes.
It's just
When it
it's
says
the homework.
calculate the test statistic, Excel going not to regression the first one?
Yeah, this one right here?
Yeah.
Right there, calculate the test statistic. Now let me show you an example. Ready?
Don't worry about it.
Yeah, right here, look at that right there. That is calculating the test statistic right there.
We don't have a number of observations though.
Yeah, you do. Look at the data, count the data. How many pieces of data do you have?
That's true.